as we can see, there's two lines over here, a blue line and a green line, which we have named L2 and L1, and they're both perpendicular to each other. So that means they both intersect at a right angle. Okay, so if you look at these two triangles, they're both congruent, which means they're the same, and the gradient of L1 would be equal to A over B, right, rise over run, which would be, let's just call that M. Okay, and the gradient of L2 would be negative B over A, again rise over run. Now if we compare this to the one above, this is basically negative 1 over M, right, because we've basically flipped this around, put it B over A, and then multiplied it by negative, which makes it negative 1 over n. Remember, the negative sign doesn't matter. It could be at the top or the bottom or here. It doesn't matter as long as you put it somewhere. So this brings us to our very first point of perpendicular lines. If a line has a gradient of m, a line perpendicular to it has a gradient of negative 1 over m. Now a great way to think about this is flip it and switch it. So let's say we have a line with a gradient of 2. If we flip this, it becomes 1 over 2, right? Remember, even a normal number like 2, in an integer, a whole number, it's still 2 over 1, right? Which still keeps it, which when you flip it, makes it 1 over 2, and then switch it. Now, what do I mean by switch? I mean switch the sign. So this was a positive sign, right? When you flipped it, it still stayed positive, but after switching it, you make the sign negative 1 over 2. Similarly, we could do something for negative, let's say 2 over 5. Now, for a line perpendicular to a line which has a gradient of this, after you flip it and switch it, you get negative 5 over 2, and you switch the sign, which makes it positive 5 over 2. So that's the first point of finding a gradient of a perpendicular line. Now the second point is, if two lines are perpendicular, the product of their gradients is negative 1. Now we can illustrate this with the first one, for example. Let's say we take the first line, which is 2, and we multiply it with the gradient of the other line, which is negative 1 over 2. This is negative 1. Now you can test it for yourself. The same would go for this one. So the product of the gradient of two lines that are perpendicular is always negative 1. So a great way to illustrate this would be with a question, right? Let's say you have a line that is perpendicular to the line, let's give you a harder, 2y minus x minus 8 is equal to 0. A line is perpendicular to this line, okay? And that line it passes through the points 5 and negative 7, okay? Now you want to find the equation of the line. So there's a line, okay? It is perpendicular to this line, and it passes through this point, and you want to find the equation of that line, okay? So to do so, first we have to rearrange this into y is equal to mx plus c. Remember in the last video we did that? So if we take this, 2y is equal to x plus 8, right? We just added x and 8 to both sides, and we get y is equal to a half x plus 4. So there's a blue line that is intersecting a green line. This is the equation of the green line, okay? Now we know that the gradient of this green line is equal to a half, okay? Now using these rules, we can say that the gradient of the other line would be flipped and switched of this line, which would be negative 2, sorry. So the blue line has a gradient of negative 2, the green line has a gradient of a half. Now we also have the information that the blue line passes through these points. From one of my previous videos, you know that to find the equation of a line, do y minus y1 is equal to m into x minus x1, right? Now we can just substitute these values into this. We keep y as is, minus negative 7 is equal to the gradient of the blue line, negative 2, into x minus 5. Right? So you get y plus 7 is equal to negative 10x plus 10. By subtracting 7 from both sides, you get y is equal to negative 10x plus 3. And there you have found the equation. Oh, sorry, I did 10. My bad. Sorry, negative 2x, and this is the equation of the blue line. So that's how you can use your these two rules. These are two most important rules when it comes to perpendicular lines, and you can use these to do basically anything with perpendicular lines in the xy plane.